Hi everyone, I'm Jonathan Campos, a Senior Product Marketing Manager focused on observability, and I'm excited to be here with you on today's Tech Talk. Let's get started. Today's Splunk Tech Talk DevOps edition is focused on auto-instrumenting a Java application with Splunk APM. And Tech Talks are a series of short webinars that are deep dives for technical practitioners. I value your time today, and I'm excited to share with you these best practices so you can leverage them in your daily role. So today's agenda is pretty straightforward. We're going to start with manual instrumentation versus auto instrumentation with OpenTelemetry. We'll get into some of the details of what each are and talk about their pros and cons. We'll also talk about how Splunk Observability Cloud makes auto instrumentation simple. Then we'll go into a demo and show how a basic Java application is auto-instrumented with Splunk APM. And then we'll talk about some additional resources to continue your Splunk journey. So when it comes to OpenTelemetry, as a quick recap, most of us already know that at its core, Splunk Observability Cloud, which includes Splunk APM, runs on OpenTelemetry. And OpenTelemetry gives you a single open standard-based set of instrumentation tools for your applications across all of your data types. So that's metrics, traces, logs, and more. And you also have more control over your data. Since you're no longer locked into any one vendor, you're leveraging OpenTelemetry, which is open source. And you also have a better return on your investment, since you can instrument once and never have to necessarily worry about doing it again. Now, every journey in observability begins with instrumenting an application to emit telemetry data. Primarily, you're going to want to instrument logs, metrics, and traces. Now, a metric is a measurement related to the health, capacity, or performance of a specific resource. And it helps us monitor and usually tell us what's going on and if we have a problem. A trace is a collection of spans or calls in a trace that represents a full request path. A good example here is an HTTP request header that contains the trace context. Now, the trace context acts like the glue to hold all the spans together. And a span is a unit of work that contains a name and a start time and an end time. And a unit of work example is an HTTP call or a database call, an API call. And last but not least, we have logs. And a log is a record of a discrete event in a system, application, or environment. Now, there are two ways we can instrument an application: manual instrumentation and auto instrumentation. Now, let's quickly take a look at what the differences are between both. Manual instrumentation means that the developer is required to change and add their application code to start and finish a span, and define payloads by use of the client libraries, while manual instrumentation is helpful in better understanding what we expect our application to do. Its concern is that we forget sometimes what we don't see. Now, when it comes to auto instrumentation, this requires no code changes at all. And with auto instrumentation, we can leverage an intelligent agent that attaches to the running application and extracts tracing data for a quick, easy start. We want to make gathering metrics simple and easy, and auto instrumentation is definitely a good start. Now let's take a look at some pros and cons with respect to manual instrumentation. Starting with the pros, we can see that you'll have maximum control over what you specifically want to see. And in minor cases, it's really the only option for certain application stacks where we do not have an auto instrumentation option to gather metrics. You can also instrument custom code blocks of your choice and not necessarily the entire application. So if we specifically want to see one thing, we can instrument that one thing. When it comes to the cons, it's simple, right? It's time consuming. You manually have to do it, and it can take away from some of your other tasks. It's also a bit of a learning curve. It requires you to have to learn how to instrument your application and specifically identify what you want to look for. And with that, of course, there's also human error. We have to factor in that since we're manually doing something, we can absolutely miss something, or in some cases, make an error. And then, of course, some of these changes require additional recompiling of your application. So that means you manually instrument something and you have to recompile it, right? So keep these pros and cons in mind when we manually instrument an application. Now, when it comes to auto instrumentation, it's plain and simple that the main pro here is that there's no code changes involved. So there's no need to change anything with respect to your code, and it provides a good coverage out of the box. So you're going to get what you need, and it saves you time instrumenting and lets you really focus on innovating or other tasks, really. Now, as far as the cons are concerned, it's not supported by all frameworks and languages. And it's a little less flexible if you just want to see one thing as opposed to the whole thing, right? Or the whole story. Now, when we look at how Splunk APM makes this process easy to auto-instrument your application, it pretty much walks you through a 3-step process. The first thing that you're going to do is install the Open Telemetry Collector, whether it's on a Kubernetes cluster or a machine that's running your application. You're going to download the Splunk distribution for OpenTelemetry, which we reference as the intelligent agent, set the environmental variables, and then update your runtime command to reflect the intelligent agent. And it's as simple as that. To auto-instrument most applications, this is pretty much the process. Of course, certain things are specific to certain platforms. Now, let's take a look at a demo of how we make this happen. I'm going to switch over to my server here. And you can see that I'm running Ubuntu 21.04. So nothing too special here. We have a simple application that simply runs HTTP GET requests to google.com. To get started, we're going to go over to Splunk's Observability Cloud. We're going to go over to Data Setup, and we're going to scroll down to APM Instrumentation. And since we're auto-instrumenting Java, we're going to click Java, and we're going to click Add Connection. Here, we'll just go ahead and add a service name as well as an environment name. We'll keep the endpoint, Kubernetes, and legacy agent as is. For the service name, we'll go ahead and enter Tech Talk Application. And let's add Java so we can quickly find that. And then for the environment, we're going to do Tech Talk Environment. We're not going to instrument this application with Kubernetes, or deploy rather this application with Kubernetes. We're simply just going to deploy it on the actual machine itself. So we'll leave Kubernetes to no. We'll go ahead and click Next. And here we're presented with that process. The first thing we're going to do is install the Splunk OpenTelemetry connector. If it's already installed, you can skip that step, but we don't have it installed, so we're going to go ahead and install it. So let's click on that. That's going to forward us to the Splunk OpenTelemetry connector wizard here. And we'll click on Linux because we're running Linux. And we'll click Add Connection. And we'll leave things to default. We do have the choice of choosing a different access token to send information to the observability cloud. But in this case, we'll leave things as default. We'll click Next, and here we can then use this curl command to download the script that will install the OpenTelemetry collector, and then we'll run a restart for the service just to make sure everything's up and running. So we'll copy this code, navigate back to our terminal, paste this curl command, hit enter. We'll enter our sudo password. The download of the script will begin and the collector. All right, looks like that's all done. We'll go back to our wizard here, and then we can see that the OpenTelemetry connector does have specific configuration in the event that you want to change the connector settings, and they're located in these directories here. There's no particular change for us to make, So what the last step is to quickly restart the OpenTelemetry collector. So let's do that now. We'll just paste this restart command to restart the service. And what I like to do is just go ahead and make sure that the service is running. We'll run a systemctl status Splunk OTEL Collector here. And we can see that the actual service is up and running. So that's good. So step one for instrumenting our Java application complete. Let's go ahead and clear the screen. Now we'll go back to the console here, to the management console. We'll click done, and we can see that in a few minutes, in about a minute or so, we'll start to see information being sent to the Splunk Observability Cloud with respect to our host to monitor our infrastructure. But right now we want to go ahead and check out how we instrument that application. So we'll go back over to data setup. We'll scroll back down to Java under APM instrumentation. We'll click Java, then click add connection again. And then let's let's place our service name again here. So it's Tech Talk App Java. And then for the environment, we'll just do Tech Talk Env for environment. And then we'll click next. And then we're presented with these steps again. Install the OpenTelemetry connector. That's already done. We'll go ahead and download the latest version of the Splunk distribution of OpenTelemetry Java. That's that intelligent agent that we spoke about. All right, and we'll copy this command here, and that's going to download it into, of course, the directory that you're currently in. So we'll do that now. And once that's downloaded, we'll run a quick ls just to make sure that that jar file is there that we're going to use to auto instrument our application. Next, we're going to go ahead and set the following environmental variables. And this is only going to tell the intelligent agent where to send all of the spans and traces. So we've emphasized our service name, which is Tech Talk Java App, and we can see that right here. And we've specified our environment name, which is Tech Talk Environment right here. And since the actual Splunk OpenTelemetry Collector is installed on this machine, we can leave the OTLP endpoint to localhost on port 4317. So we'll copy these environmental variables, we'll paste them, we'll click enter, or we'll hit enter rather, and then we'll go ahead and update our runtime. So let's take a look at our runtime here. So to launch this Java application, we'll normally hit Java, and then we'll specify the Java agent, which will leverage that intelligent agent, which is the Splunk OTEL Java agent.jar file, which we've downloaded already here with that previous curl command. And then we'll emphasize the application that we want to run. So let's copy this code as reference. We'll paste it and just quickly modify it here so that we can emphasize our application. So we'll say jar, and then we'll say curl app here for our jar file. So we'll execute that, and then we can see that the application starts running, and we can see the 1, 2, 3, 4, 5, and that number just starting to increase and increase. And these are the GET requests that are occurring to google.com. Again, a simple application to quickly see how we can auto instrument the application. So let's go back over to the administrative console, and we'll go ahead and click next. And then we'll go ahead and explore service spans. Now, it takes about 90 seconds or so to start seeing your data in Splunk APM. So what we want to do is we want to emphasize the environment that we've specified, which of course was Tech Talk environment. So we'll wait a few seconds here and wait for the application to begin enumerating on the management console here. So after a quick refresh, we can go over to all environments, and we can see that no data has been sent to APM just yet within the specified time range. What I like to do is, of course, change that to the last 5 minutes. And we can also click on the environments and we can see that nothing has been populated yet. So again, it does take a second or two to come in. All right, what we'll do now is we'll go over to our dependency map for all environments. We can see that nothing is here just yet. We're going to need to give it, again, a few more seconds here. And I know that with a demo, sometimes waiting is not the best. All right, so we can see that our Tech Talk environment now is present, and we can start to see that we do have data. So we've seen that we've changed that to less than 5 minutes, and we can see that our Tech Talk environment is labeled and present. And that's of course based on those environmental variables that we've set, right? So you can see here, I have a couple of tests that I've completed here. And what we can now do is we can quickly go and look at our service dependency map. And of course, we don't see really many other services because it's just one simple application that's actually just getting google.com or HTTP getting google.com. But we can quickly hover over this and we can see the amount of requests that are happening per second. And we can see certain red metrics. Again, this is exactly what happens when we auto instrument the application. If we move over to Tag Spotlight, which is that one-stop shop to kind of see what's going on with respect to the application, we can quickly see that the method is a GET request. We can see that we've sent about 144 of those requests, and we can actually click on latency here, and we can see some of these metrics with respect to the latency, but it's that simple to quickly auto-instrument your application. Now we're going to go back over to the presentation here. And let's move on to the next slide here where we have some additional resources. Now, these resources are great to continue your Splunk journey. So we have blogs, we have great documentation to learn more with respect to other platforms. We have videos available, as well as some step-through Splunk APM walkthroughs. And these are great because this will actually walk you through how to auto-instrument or in some cases, manually instrument your application. Also, feel free to sign up for a free trial if you want to try this yourself. So with that, I also want to emphasize that you can continue the conversation on community.splunk.com. Here you can sign up to our community and you have access to Splunk answers, to search the tag, APM to view and share your best practices. You can get involved with the discussion, as well as share some of your ideas and vote for some request enhancements. I also want to add, before we wrap up, that we're currently working on increasing our presence on peer review sites like Gartner Peer Review. If you have a second, we would really appreciate it if you could leave us a review. And with that, let's go ahead and move on to Q&A.